Welcome to Pomodoro Joe for Sunday, April 23rd, 2023. Today we're doing LeetCode problem 1416, restore the array. This is a hard problem. A program was supposed to print an array of integers. The program forgot to print whitespace, and the array is printed as a string of digits, s. And all we know is that all the integers in the array were in the range from 1 to k, inclusive. And there are no leading zeros in the array. Given the string s and the integer k, return the number of possible arrays that can be printed as s using the mentioned program. Since the answer may be very large, return it modulo 10 to the 9th plus 7. Okay, and then we have some examples. So s is 1000 and k is 10,000. So the only option we have is 1000 because the others would have leading zeros. All right. Example 2, 1000 but k is 10, but the answer is 0. There are no ways we can create an array out of this because if we had 10, then we would have leading zeros, which we're not allowed to do. And then finally, we have 1317, and that's k is 2000. So this could be 1 and 317, or it could be 13 and 17, or it could be 131 and 7, or it could just be 1317. And then there are things in between where it's like 1 and 31 and 7. Yeah, so there are 8 possible ways. All right, and our constraints. We have 10 to the 5th, up to 10 to the 5th characters. All right, we have no leading zeros, and we have between 1 and 10 to the 9th for our k. All right, so before we start, let's do a little bit of breakdown of this problem. So first thing I'll note, we'll do the last example here, 1317. So we're getting a string, 1317. Since we're going to be doing some number comparison against k, I think the first thing I want to do is convert these into an array of integers. So we'll have 1, 3, 1, and 7. So that'll be my first step, convert the string into an array of ints. Next, let's see. I think I want to break this out into the individual components. So we'll have, let's see. So our initial input will be like 1317, but that can be a 1 plus, and then the remainder of that, which would be 3, 1, and 7. Or this could be 1, 3 plus the remainder of that, which would be 1 and 7. All right, so a pattern's starting to form here. And then I can do 131, and then that'll be plus whatever's left, which is just 7. Let's just line these up a little bit. Okay, so I'm starting to see a pattern where I create, I'll call this the prefix. So we have some prefix number here. And so that prefix number has to be below k, or less than or equal to k. So we have some prefix number, and then we have whatever's left over. So this is our remaining number. And it's not even a number, this is a remaining array. So with our remaining array, we'll recurse. So we'll basically say, let's grab this first number, or this first prefix number, however long it may be, and then we'll just call whatever our function is on the rest of the numbers. This is where recursion has this sort of magical thinking where it's like, okay, so if I have a function that will tell me the number of possible arrays that I can create out of the given array, then I can just grab the first part and say, is that valid? And if it is valid, now if only I had a function that will tell me how many different ways I can make a valid array out of the remainder. Well, that's the same function. So given an array, tell me how many valid possibilities there are. I'll just grab the prefix number off the front, and then we'll recurse. We'll call the rest of our array. So I'll just grab that prefix off the front, and then I'll recurse on the remainder of my array. So building up these prefix numbers is going to be a little bit interesting. So that's not going to be our normal recurse. I think I'll end up using a for loop or a while loop. So we'll keep going through finding numbers until we've exceeded our k, and then we can't recurse anymore because we know that that's not a valid number. All right, let's put 25 minutes on the Pomodoro timer and get started. Okay, so we'll start with some basics here. So we'll have some result. That'll be 0, and we will return our result at the end. All right, now the first thing I do want to do is convert this string into an integer array. So I'll have some n, that's going to be an array of integers. And for every character in our string, we'll just say n plus equals the integer version of that character. And I have to wrap that in a list so I can do an append here. Okay, so now I have my list of integers instead of just having a string. Let's print that out and make sure that that works. This won't give me the right answer, but I just want to print and see that I'm doing the right thing. Yeah, so it took my string of 1, 0, 0, 0, and it gave me 1, 0, 0, 0. Cool. All right, now let's create our recursive function. So I'm just going to call it number of arrays recurse. All right, and so what will this take? Well, the idea is we just want to say from some index to the end, how many different ways are there to create a valid array? So I just need to take in the index here. All right, so from this index to the end of our array, how many ways are there to create a valid array? So first thing I'll check is, do we have a valid index? This is one base case. All right, so if this index is greater than our maximum index, then we'll just return 0. We can't create any new array from this. But I'll need to get my max index out here. So the max index will be the length of our s minus 1. All right, so base case number 1, do we have a valid index? If we don't, we'll return 0. Base case number 2, do we have a valid prefix? So if n at index is greater than k, because k is our thing that we have to be less than or equal to. So if n at index is greater than k, then we return 0. We can't do this. Okay, now we get to our recursive call. So we have a valid index and we have a valid prefix. So let's just call that prefix. So what I sort of want to do is just say, all right, if our prefix num is less than or equal to our k, we know it's valid, then I'll recurse. Let's see, I'll need to keep track of some result here, so let's do that. So if our prefix number is less than our k, then our result will just be increased by whatever our recursive call is on the rest of our array. So we'll just do number of arrays recurse, and that's going to be index plus 1. So we can just move on to the next number in our array. So this only works for our very first number though. So in our example with 1317, this only looks at 1. It doesn't look at the rest. So we need to build up these other ones, the 13, the 131, and the 1317. So let's convert, well, let's see, before we do this, let's return our result, make sure we're doing all the things we need to do here. So we return our result here, and then outside, we will need to do our recursive call, our initial recursive call, to start the whole thing off. So we'll have some result equal to our whole thing, and we'll start at index 0. Let's just do a little bit more separation there. All right. Hide this. Okay, so far what we've got is we have our maximum index. We've gone through, converted our string to an integer array, and then we have our recursive function, and we will do our initial recursive call starting at index 0, and we'll return that result at the end. Oh, but we need to return that result modulo 10 to the 9th plus 7. So let's do that here before we forget. Okay, so now we've got the right modulo for our result. Now in here, we're only currently looking at that very first number. We need to build up all the prefix numbers. So the way we do that is we need to keep track of what is the index that we're on for our prefix. So I'll call this like prefix index. That's going to start at the current index. Now instead of saying if our prefix number is less than k, we're going to say while the prefix number is less than k. And then we'll keep adding digits to our prefix number. All right, so while the prefix number is less than k, and we better make sure we don't exceed our array here. We don't exceed the bounds of our array. So then we have to look at our prefix index. It has to be less than the max index. Well, we'll still want to do this result number of arrays recurse, but instead of our current index, we want to start at the prefix index plus 1. So the prefix index will be the end of our prefix. So our start index is always going to be the current index. And then the prefix index, well, let me see if I can diagram this out really quick. Okay, so this isn't a great diagram, but the idea is we start at this current index, which is the start of our prefix number. Now, at the beginning, the index and the prefix index are the same place. But then we'll be moving our prefix index as we add new digits onto our current prefix. So our index will stay at this first digit here, but our prefix index will keep moving over as we add more digits onto our prefix. And then this is our prefix index plus 1. Let's see if I can add that. So the next recurse call starts at prefix index plus 1. All right, so we have our prefix index, we do our recursive call on the prefix index plus 1. Now we need to change our prefix from this 1 to this 1, 3. So we basically need to shift our current prefix to the left by 1 to make room for this next digit, which will be 3. So let's see, that's pretty straightforward. We can have this current prefix num. That's going to be equal to our prefix num times 10 plus the new ones place. Okay, so here's our while loop. We'll check our prefix. If our prefix number is less than our k, or less than or equal to our k, we still have a valid prefix. And as long as our index is less than our max, we haven't exceeded the end of our array, then we can call result will be equal to the result plus the number of ways you can make an array from that next index on. So from the prefix index plus 1 to the end. Then we need to update our prefix number itself. So it goes from 1 to being 1, 3. And to do that, we have to shift it to the left by multiplying by 10. So the 1s becomes the 10s. And then we add the next prefix number. So that'll be this prefix plus 1. So that becomes 1, 3. And then we have to increment our index, so we keep moving down the line, getting more and more prefixes. Now you notice I had prefix index plus 1 here and here and here. So we can actually consolidate all of these into one. There we go. And we don't need this one. And we've already done this at the top. Cool. So this gives us our basics. Now, one thing you'll notice, we don't have any place where we're actually adding 1 to our result. At this point, our result will always be 0, because there's no point where we're getting to the end and saying, yeah, we can add 1 to this result. So where do we add 1 to the result? Well, how do we know we've got a valid array? There's only one way we know that we have a valid array, and that's when we get to the very end of the array and we haven't had to exit out early because we have a broken piece, like a leading 0 or a number that's too large. So how do we know that we have a valid array? Well, we've got to the end of our array. Well, when do we get to the end of our array? Well, basically up here. So this early out that I had up here, where I said if the index is greater than the max index, return 0, I don't think that's right. I think we actually want to return 1. We've got to the end of our array without exiting early. We've got a valid array at this point. Okay, let's see if that works. I think we can do it here, or we could do it at the end out here, which might save us a recursive call. But we can come back to that. Okay, let's see if this works. Typos. All right, let's just go through and make sure I don't have typos. All right, and we're looking at prefix index, prefix numbers. Okay, try this one more time. We're returning 0 and we're returning 0 because we need to go up to the max index. Or we need to see if it's greater than or equal to, but I think this one will work. So the problem there was we were going only up to 1 before the max index, which means once we do this plus, then we've got the max index, but I'm only checking if I'm greater than the max index, so we would never hit our end condition. Now I think it should work. Out of range, right, because we're going up to the max index, then when we add here, we could be going out of range. Of course. So out here, we'll just say if our prefix index is greater than our max index, we'll break. Okay, one more time. And we're still getting the wrong answer. We're getting way too many. I think what we really want to do is move this out here. We have to make sure that our prefix number is still valid. So if we have a prefix number, and we have to make sure it's not 0. So if you have a prefix number and the prefix number is less than or equal to k, and our prefix index, do I have that still? Yeah. And our prefix index is greater than our max index. All right, now at this point, we should have the right answer. Our result will be plus equals 1. And I do think at this point then, I don't want to do double adding, so let's put that back to 0. All right, so that seemed to work. Let's take this whole thing and submit it. Actually, before we submit it, no, let's submit it first. I'll come back and fix any runtime issues later. Okay, and we have a wrong answer. It's supposed to be 1 and we output 3. Oh, we're doing the one thing that we really need to be doing, or we're not doing the one thing we really need to be doing. So this check here, if the index is greater than k, we can return 0. Well, we're already going to do that down here. We don't need to worry about this. But what we're not doing, we haven't counted on our leading zeros. So if our index happens to have a leading 0, then we have to return 0. Okay, let's use this test case and check that. So that was it. I completely forgot the leading zeros. My mistake. So that should have been our very basic base case. All right, let's submit this and see how we do. All right, time limit exceeded, but we passed 28 out of, let's see, 83. Not too bad. So let's use this test case. Now, the brilliant thing with this solution is because this function only takes a single integer as its input, we can cache the results for all the recursive calls. So let's turn to our old friend functools caching. So up here, from functools import cache, and then down here we will decorate this with @cache. All right, now we're passing. Let's try this one more time. Still time limit exceeded, but we're getting 80 out of 83. Much better. So we'll still use that test case. A couple things that we can do here. The first one, and the easiest one, is we're going through, we're returning this result, and then only at the end are we returning the result mod pow 10 to the 9th plus 7. But that means or potentially keeping some very, very large numbers right up until the very end. We can do better. We can actually do this modulo here so that we don't have to do it. Well, we still have to do it. We can do this modulo here, which actually results in smaller numbers being added, which should give us some runtime improvements. And in fact, we can keep this, so we're not doing it over and over again. We can call it mod num. Now we only have to do this here and here. All right, try that. All right, now we're passing that test case. Let's see how we do. And we pass. Whoa, look at that. We crush it. We're beating 100% for runtime and 24% for memory. Ooh, baby, that is awesome. Oh man, I'm really happy about that. 100% runtime. So one thing I was going to show you, this is icing on the cake. You don't need to do this, but so this function here, we have n. We're creating our array of integers out of our string. We can consolidate this. We can use something called the map function. So what a map will do, it will apply a function to every element in an iterable and return a new iterable with the same elements replaced with the function called on that element. That doesn't make any sense. Okay, but what we can do is we can say map, we're going to map the int function over our string. Now that's going to return, it's actually a map object, so we're going to put that whole thing in a list. But basically this will return a list of all of the elements of string converted to integers. So this will do the same thing that we were doing before. Just a little bit nicer, a little bit cleaner. And yeah, it still works. All right. So that's pretty much it. I'm just going to submit this and see if it makes a difference using this map function. It might make it worse, but we already got 100%. Oh, it's exactly the same. 100% and 24%. Yeah, it's exactly the same. Okay, so we'll take a quick look at this and then we'll wrap it up because we're down to 3 minutes. But we have our outer function where we have some basic variables to start with. We have a max index, our mod number, which is 10 to the 9th plus 7, and then we have our list of integers, which is the string converted into a list of integers. Then we'll have a recursive function. We're going to use cache to cache out the results so that we don't have to do the same function call multiple times. Or when we do the same function call multiple times, we don't actually have to run the function. We can just return the already calculated result. All right. So if our index is out of bounds, we return 0. If our array starts with a 0, we'll return 0 because there are no leading zeros allowed. Otherwise, we have our new result. We'll go through and we'll build up our various prefix numbers. So we'll basically go, while our prefix number is less than our k, we can keep building on it. And we keep track of how long the prefix number is. So we have our prefix index. And we'll go through. If we have a valid prefix, then we'll make a recursive call on the remainder of the array. And we'll add that to our result. If we're out of bounds, we'll just break out. Otherwise, we'll increase our prefix by adding a new digit onto the right of our prefix. At the very end here, we're done with all our prefix numbers. If our prefix number is still valid, it's not 0 and it's less than or equal to k, and we've reached the end of our array. We've finally reached the end of the array. We know it's a valid array. We can add one to our result. Then we'll return our result mod that mod number. And at the very end out here, we're starting the whole thing off with this first call at index 0. Okay, we're down to a minute, so I would say try to improve on this one, but I don't know if you can. This is the best it'll ever be. This is so good, there's no way to improve it. I'm just kidding. You can do better on memory. See if you can do better. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.